Okay, so today it's 2.1. We're doing 2.1. We're going to analyze piecewise functions, stuff that we did the last unit, so it's a continuation of that. We're going to step it up just a little bit in that we wrote the equation given a graph for maybe a restricted area, or I think we did like just write the piecewise function here that's this absolute value over this interval. Okay, we're going to write the whole thing today, as well as look at some other information. Okay, so we need to start with a graph. So would you set up an x and a y axis here? On the x-axis, I would like for you to go from -6 to +6. So count off 6 in both directions. And on the y-axis, let's go just -4 to +4. Okay, and then here's the points we need to have. I want you to have the point -6, -4. Put a point there. And then -2, 2. And just draw a straight line to it. You're going to see the point -1, -1, 0, 2, 1, -1, and then 2, 2. And this is going to be a U shape. And then it's going to go straight over to 6, 2, like that. And just because we're kind of freehanding these, today they'll be given on a nice grid. Let's go ahead and label what these points were. So this was -6, -4. This was -2, 2. This was 0, -2. 2, 2. And 6, 2. And this function is called f of x. Y equals f of x is the name of this function. Okay, now we're going to go through and answer a series of questions about this. Okay? 1. I want you to state the open interval or intervals, so you'll write that. State the open interval and then put a parentheses S at the end of that, on which f is increasing. Pretty sure you guys have done this before in Math 1, but what you've never done is put it in an interval notation, so this will be new. Okay, but we know interval notation. Okay, so here's what you're going to look at here. When it says state the open intervals, what that means, you guys, is we're just going to always do parentheses for when it's increasing or decreasing. Okay, we're always going to do parentheses. There actually is not agreement in the world of calculus or in the world of math as to whether right at, say, right here at -2, is that function increasing or decreasing? There's not agreement. Some would say, you know what, coming into -2 it's increasing, and so I should put a bracket there for increasing if it's coming into it. Some would say, well, no, right at -2 it's neither increasing nor decreasing, or it's doing both, so you can't put a bracket. So because there's not agreement, what it will say is just make it an open interval. We're just going to go with, let's just use parentheses instead of brackets, okay? When we get to domain and range, we'll definitely put the brackets if we need them, okay? But for this increasing, decreasing, we're going to do parentheses. So as you look from, and you want to read it from left to right, yeah? If I read it from right to left, this would look like it's going down. But if I read it from left to right, it's increasing. Okay, so as I go from here to here, what I'm asking you for is, what are the x values where it's increasing? So it starts increasing right here until here. What are those x values? -6, -2. And that's how you're going to write it. You're going to write -6 to -2, and you're going to put parentheses because of this word right here, open. Open means parentheses. Okay, closed would have been brackets. So is there any other place where as you go from left to right, this graph is going up?
0, 2.
What would it be, Jason?
0,
0 to 2. Right here, this 0 to this x value of 2. So the way we write that, or union 0 to 2. Okay, we put the union there for increasing. It's increasing on either of those, right? That's what that means. Okay, question number 2 is going to start the same way. Can we just go state and then go dot, dot, dot? So it's going to be state the open intervals on which f is, and also go ahead and write the f is, on which f is, and then decreasing. Okay, so same thing, open intervals, so we're going to use parentheses, not going to worry about brackets. Where is f decreasing? Again, as you read from left to right. Well, it looks to me like from right here until right here, it's decreasing. So what's the x value right here? -2 to 0. So I'd write -2 to 0. That's the interval over which it's decreasing. Any other place that it's decreasing? No. Okay, what was this called if it neither increased nor decreased? What was that called? Anybody remember? We did this a couple years ago. We'd say it's staying something. Staying, it's not going up, it's not going down, it's staying constant. Yeah. So this one will also have a state. Can we just do state dot dot dot? State the open intervals on which f is constant. So it'll ask that if there is a place where it's constant, typically. Okay, so again, you're looking at, I want the x values. What's the x values over which it's constant? Well, obviously from here to here, what's the x value? 2 to 6. Okay. So again, these are intervals. These are intervals, and you would know that because the question asks you to find the intervals. So kind of in the context there, I can tell they're intervals. Now we're going to go to coordinates, and coordinates are going to look the same, right? They're going to have parentheses around them, but it's going to be coordinates based on, again, the context of the problem. So actually 4, 4 is still the interval. I want you to find the domain and the range. This is old. This is what we were doing from the last unit. Domain and range. Okay, tell me, what's domain, x or y? X, right? So for domain, because x is left to right, what's the furthest x to the left, what's the furthest x to the right, and are there any that are skipped with an open circle somewhere? Okay, so furthest x to the left, -6, and since that's solid, I'm going to make it a bracket. Okay, so bracket -6, and then this is nice and continuous. It continues on and on and on and on all the way till here. What's the x value there? 6, and it does hit it. It's solid, so I'll put a bracket there. That'll be my domain. Okay. Range is the y value, so lowest y to highest y. What's my lowest y? -4. And what's my highest? 2. Does it hit both of those? Yes. And every point in between has a corresponding value, so we would include all those. Okay, so you'll do that the same. You'll do those with brackets. It won't say open interval for domain and range. Okay, it'll just say find it. So do that the same way as we did last unit. Okay, now number 5. I want you to state the coordinates of the relative min. State the coordinates of the relative min. Relative min. Which is, we're going to abbreviate RELMIN from here on out, but we'll write it out this first time. Okay, what needs to happen to have a relative min is your function needs to go down and then up. It needs to decrease and then increase, and it could do it sharp or it could do it nice and smooth. Okay, but it needs to decrease and then increase. Okay, so keep that in mind for a relative min. F decreases, then increases. Whether it makes a sharp turn or not doesn't matter. Okay, so just it needs to decrease and then increase. That makes a relative min, as opposed to the absolute min would be the absolute lowest point. That's not what I'm asking. I'm asking in a small little area, where did it decrease and then increase? Okay, so as you look at that, do you see any spot where the function decreases and then increases? Yeah, where? What's the point at which it changes from decreasing to increasing? right there, right? So the coordinates there are 0, -2. See, this answer kind of looks like what we were doing up here, but this is not an interval. These are coordinates. You got to base it on the context here. So the coordinates of the relative min, the place where f decreased and then increased, changed from decreasing to increase, was right at 0, -2. So I guess I should have said here, relative min is where f changes from decreasing to increasing. It changes at that point. Okay, so guess what the other one's called, where it increases and then decreases? Relative max. Okay, so can we go state the coordinates ... of the relative max? And so this is going to be the point where f changes from increasing to decreasing, and it could be a nice little hill or it could be a sharp peak. Doesn't matter. Just needs to change. Is there a spot here where the function changes from increasing to decreasing? Do you see it? -2, 2, right? Right there. And so that would be your answer. Okay, now you guys, this is not a relative min. It kind of looks like it, relative max, sorry. It looks like it wants to be, but why isn't it? Yeah, it went increase and then constant, and it said it's got to change from going up to going down to be a relative max. Okay, did I say that right? Did I say any of that backwards? Some of you are looking at me like, okay, thought maybe I said it wrong. Okay, then the fun part, number 7. Ready? We're now going to write the 3-piece function. A 3-piece function. We graphed these. We went the other way in Unit 1, okay? So now it's going to be backwards. All right, we're going to come backwards here. And here's what this is going to look like. You're going to write f of x equals. You're going to set up a big brace because we need 3 pieces to this, okay? And let's go left to right. Let's name them, first of all, going left to right. Look at the first piece. Can you tell me what it is? This piece right here would be a, what's that called? A line, right? So it's going to be linear. Then this is going to be the next piece, which is a quadratic, and then a line again. Okay, so we got to do a line, a quadratic, and then a horizontal line. So let's do this line first. To do the line, we need the slope, right? Okay, so now again on a grid, it's going to be a little nicer because we'll just be able to count how far up and how far over. But let's see if we can figure this out. We were down at -4, and we went up here to a +2. So how big was that change to go from -4 to +2? How far up did we go there? 6. We went up 6, and then this distance would be how far over? We were at -6 and we got to -2. What's that difference? 4. So we went up 6, right 4. So if I was going to write that as a slope, that would be 6 over 4, which reduces to 3 over 2. That's my slope. Then you can pick either point that you can see, either -6, -4, -2, 2. Let's go with -2, 2. Okay. To get to this point, we would have shifted left 2, up 2, right? From 0, 0. Okay, how do I get a left 2 shift? I need an x plus 2 in parentheses. How do I get, was I off the screen there? How do I get an up 2 shift? Plus 2 outside, okay? Or I could have written it with the -6, 4. I could have gone, you know, left 6 and then down 4. It doesn't matter. You can pick either one. Okay, so you got to get that equation. Now let's get the restriction. I want this to go from my x values. You're looking at x values from when x is -6 until x is -2. I'm going to write that this way. -6 is less than or equal to x is less than or equal to -2. I'm putting equal signs because both of those are solid. Okay? So you just make a little sandwich from the furthest to the left to the furthest to the right. Okay, now for the next graph, I'm going to look at this quadratic and I'm going to come up with the equation of this. Okay? Here's the vertex. It normally is at 0, 0, so it's been shifted down 2. Okay? I'm going to leave a space for the a. To get a down 2 shift without a right or left shift, I actually don't need to subtract anything here, right? It'd be x minus 0, so I didn't really need these parentheses. To get a downshift, then -2, okay? to get that a value in front, what I need to know is 1 over, can I tell how far up I went? Because it's up a over 1, right? Not the little shortcut for this. Do I know for sure how far I went? Do I know for sure where that was? Yeah, it looks to me, I can see those points. I went up 1 over 1. Okay, if I didn't know that, I would need to, off the side, put an a in there and then pick another point and plug it in. But since I already know it's 1, that's it. I've got the equation for that. Okay, now this quadratic then, to get the x values, goes from -2 all the way until it gets to 2. Now here's a problem, you guys. If we already included -2 here, you don't want to include it again. Okay, don't put an equal sign again. And so you actually get to pick which one, and since I already included it with the first one, I'm not going to include it with the second one. The idea then is that I would have had an open circle and a solid dot lined up together. Which one wins? The solid dot, right? So I'm not going to include it here. Again, we don't do that because then these wouldn't be, theoretically, it wouldn't be a function. Okay, so you don't want to include that twice. Then you get the choice. We're going to go all the way to 2. You get to choose which one you want to include it with. Do you want to include the 2 with this quadratic? You can't see what I'm pointing to here. Do you want to include it with the quadratic, or do you want to include it with this horizontal line? It really doesn't matter. Just put it with one of them. Okay, so Caleb, you tell me, you just get to pick. And again, it doesn't matter. Do you want to include it now with this quadratic, or do you want to include it with the line? The quadratic. Okay, so I'm going to put an equal sign here with this 2. So this says do the quadratic when x is between -2 and 2. So we won't include it after that then. All right, the next thing then is this horizontal line. How do I write the equation of a horizontal line? Yeah, this is just what's it at. We would write y equals 2, because we've already written the y equals part. That was this. So it would just be 2. You just have to write the 2. Okay, and then what I'm going to go from is from 2 until 6. If you look back at that, the x values go from 2 to 6. Okay, I'm not going to include this 2 because I already did that. I don't want 2 equal signs to the same number. Do I need to include the 6? Yes, because it's solid there. So I will put an equal there. Okay, like I said, that's the funnest part. All right, we're going to do one more of these, and that's it for these notes, okay? One more. All right. One more drawing here. All right, set up an x and y axis. Again, we're going to go from -6 to 6 on the x-axis, so count over 6 in both directions. And go ahead and go -4 to 4 on the y. Okay, so first point, plot -6, -2. Plot -4, +2. -2, -2. And I want you to make an upside down U. Plot 4, 4. And from this guy, go straight to it. Plot 5, 1. You're going to be able to see the point 6, 4, but the graph's going to go like this. It's going to come down, and then it's going to go through that, but it's going to keep on going with an arrow. So this one stops. This one doesn't. Okay. This is y equals f of x. Again, since we were just creating these, can we label these points? So the first one was -6, -2, -4, 2, -2, -2, 4, 4, 5, 1, and then we could see here 6, 4, but it didn't stop there. It just went through it, but that's helpful to know that it went through that point. Okay. All right, we're going to go through and answer these questions. Maybe go just a little bit faster. Let me know if I'm going too fast. Okay. 1. Where is F increasing? F increasing. And it's going to say state the open intervals. So we're just going to use parentheses where F is increasing. As I read from left to right, where is it going up? Anybody want to give it a shot? Go ahead. What do you think? -6 to -4. Yeah, it's going up there. Okay, so I'm going to write the interval -6 to -4. There's more, right? So I'm going to put the union symbol. -4 to -2, no. But here, right? -2 to 4, it's going up. Here it went up. Not here, but here it did. Now how I'm going to write this one? 5 to infinity, right? It just keeps going on and on and on and on forever. Okay, so that's where it's going up. Part 2 is going to be where is F decreasing? Where is F decreasing? Okay, so where's it going down? It starts going down right here. What are my X values? -4 to -2. Any place else where this function goes down? Decreases? Right here, right? So from 4 to 5, again, you're looking at the X values. Any place else? No. Does this have any place where it's constant? Again, some would argue that, well, right at that point it's constant. I don't know. Coming in, it's going up, going out, it's going down, but right now, not really. You're going to look for an interval where it's flat for a while, and it never does that. Okay, so we're not going to answer the constant part. 3 then is the domain. Domain is which values again? X. So how far left does it go? How far left does this go? -6, and it hits it, right? Bracket. How far right does it go? Forever, right? So infinity, and we always put a parentheses with infinity, right? The range, that's how low and how high. How far down does it go? -2, does it hit it? Yes, so we'll put a bracket. How high does it go? Infinity, and there's no breaks in between. It just, even though it kind of goes up and down a while, but right here it's going to keep going up forever. Okay? Number 4 then, I want you to give me the coordinates of the relative min. F has to change from decreasing to increasing to do that. Do you see a relative min here? F has to change from decreasing to increasing. Yes? That one right there, yeah. So that coordinate, what's the coordinate right there? 5, 1. 5, 1's one of them. There's another one. -2. -2, -2 would be the other. We would say here and. Those are both relatives mins. So and, both of those. 5, 1 and -2, 2. Any other places where it changes from decreasing to increasing? No. Why is -6, -2 not a relative min? It's not decreasing before. It's got to decrease and then increase, and it doesn't do that. So, okay. Is there a relative max? A place where it changes from increasing to decreasing?
Yeah.
Where?
4,
4,
4.
4. Any others? -4, 2. Yeah, both of those would be, oh, +2. Wow, got the negatives backwards. Both of those would be relative maxes. We good with that? Okay, the fun part. Write the equation. So here we go. Let's write. In this case, I want it to be also a 3-piece function. Write a 3-piece. I would need to tell you this, that it needs to be 3 pieces. The other thing this could be is a 4-piece. Anybody know why I would need to say it needs to be a 3-piece as opposed to a 4-piece?
If you said 4-piece, we would do 2 linear function with a linear absolute.
Okay, so this last one, she's saying if we said a 4-piece, we would do a line and a line. Instead, this is going to have to be an absolute value. It has to be, right? But an absolute value could be written as 2 line pieces as well. So Based on that, then we know this is a linear absolute value. This one is a, what's this one called? Quadratic. And this one's going to be the line, and then the last one would be the absolute value. How do I know it's the last one and not this one? Why couldn't it be this one as my absolute value? Why would I know that, Jason?
That one can't be split into two.
This one can't be split into two. Well, I could write this as a line and I could write this as a line, but why isn't this the absolute value?
It doesn't have the same slope.
Doesn't have the same slope, right? You'd have to have, you know, whatever this positive slope was, this negative would have to be the same, and they're different. Okay, so that's how I know this. These, though, this has this negative slope, this positive slope have the same absolute value. All right, so let's write it. F of x equals, set up a big brace. We're going to start with the quadratic. Let's leave a little space for the a, and let's first get how it has been shifted. This is where it's been shifted, right? So from here it was shifted left 4 up 2. How do I get a left 4 shift? Minus 4 or plus 4? Plus 4, right? And then it's quadratic, so I need the squared. And then to get an up 2 shift, I would go minus 2 or plus 2? Plus 2 outside, right? The up and down is the same. Inside, left, or right is the opposite. Okay, now, to know the a value, I would need to know 1 over exactly where I was. So here I was at negative 4. At negative 3, do I know for sure that that's at 1? It looks like it's at 1, but do I know that for sure? No, that point's not given. Okay, so here, off to the side, you're going to put an a in front of this. I'm going to rewrite this as y equals, I'm going to put an a there, x plus 4 quantity squared plus 2, and then I'm going to plug in a point that I do know. I don't know these, but I do know these guys down here. They're on that quadratic, right? So I'm just going to choose negative 2, negative 2. Out of room here a little bit, but I'm going to evaluate this at negative 2, negative 2. Okay? So plugging in negative 2 for y and negative 2 for x. I'm going to try to figure out what a is here then. Okay? Negative 2 plus 4. Yes? Trying to do it on here since I'm recording instead of on the whiteboard, but can you see it now? Is that better? Is that better? Okay, so let's do this part. Negative 2 plus 4 is 2 squared. 4. This becomes 4. Can I add this to? No. Put it with the a, right? It's 4a plus 2 equals negative 2. You want to subtract the 2 then, and we'd get negative 4 equals 4a. So what's my a? Negative 1. Okay, so it did. It kind of looked like it didn't end up, but we do need the negative, which we could have figured because it opens down. Okay, let's get the restricted domain now for this. All right, what are the x values that this quadratic goes from? Negative 6 all the way until negative 2. So I'm going to set up a sandwich. Negative 6 is less than x is less than negative 2, and then I'm going to figure out if I need equal signs. Do I need one with the negative 6? Yes. Okay, and then with the negative 2, this is where you get to pick. Do you want to put it here? You want to put it here? Okay, so let's put it with the quadratic. We'll put the equal sign there. All right, let's do the next one. I'm going to zoom back out a little bit. This next one is this line. To do the equation of a line, I need the slope. What's the slope of this? You could go from this point to this point, and since we know those, how far up would I go? From negative 2 up to 4, how far is that up? That's up, we went up 6, and then we went from negative 2 to 4 over 6. Up 6 over 6 is 1, okay? So my slope is 1. I don't need it. I'm going to open a parentheses, put x, pick one of these. Melanie, pick one. Do you like negative 2, negative 2? Oh, sorry. Or do you like 4, 4? Sorry, you couldn't see what I was doing there. Okay, so to go negative 2, I shifted left 2, down 2. How do I get a left 2 shift? Yeah. So what goes in here? Oh, plus 2, and then negative 2. Yeah. And that's fine, or if you had done 4, 4, you could have gone minus 4, plus 4. If you drop those parentheses, you also could have gotten just y equals x. Does this look like the line y equals x? If we drew it right, yeah, I went through 0, 0. So either way, though, any of those are fine. All right, now let's get the x values. that that line goes between. Looks to me like it starts at -2 and it stops at 4. Okay, so I'm going to set up a sandwich. -2 is less than x is less than 4. Then I'm going to figure out equal signs. Okay, we're not going to put it here with this -2 because we already put it here. Then we just need to decide, so it does hit this, do we want the equal sign here? Jordan, you pick. Do you want it here or do you want it on the next one? The equal sign, it doesn't matter, just pick. That one, okay? So we'll put equal sign there, so we won't put it on the next one then. All right, for this last one then, we need an absolute value, right? To do an absolute value, I need to know the slope. Can you tell what the slope is? I was at 5.1 and I ended up at 6.4. What is that? Up 3 over 1. Do you see a 3 slope there? And it would be positive since it's opening up. Okay, so I'm going to start with the 3. I got to put the absolute values in. Have to pull these out of the air, right? Okay, then how has this been shifted? This 5.1 is what's been shifted. We went right 5, up 1. How do I get a right 5 shift? -5, right? How do I get an up 1 shift? +1. Okay, now this last one's a little trickier to get the restricted domain because it actually starts, the absolute value starts at 4, right? But then it keeps going on and on and on forever. How would I write that? Starting at 4 and going on and on and on forever as an inequality. What would it be? X is greater than 4. Yeah. Yeah. And I don't want to